ZKGM, can you guys hear me?
CKGM, can you hear me,
Yeah, hello,
guys?
sir. How are you doing?
Hey, Carlo, all good. Thanks for having me here.
Yeah, no worries. Excited to chat a bit about the ceremony and some security-related things. And I see we also have Cor and Robert from the union team. So if we want, we can also expand it a bit if we want to make this more of a banter session.
Yeah, I love that. I mean, I think like the ceremony that you guys are doing, like I'd love to learn much more about it and also talk all things, like of course breach and interoperability security. I think that we have a lot to talk about. So yeah, happy to make this as dynamic and as long as what you guys want.
Yeah, sounds good. So, for the listeners, brief intro about me. I'm Corel, CEO of Union, developer for I know like almost a decade now. Previously CTO at Composable, so you can ask me any technical questions you want as well. And I'm here with Andres from Range Security.
Yeah, so some words about me as well. So I am Andres Monti, co-founder and CEO at Range Security. Yes, like my background is actually in astrophysics, but I've been working in the industry for about 6 years now. I started as a research engineer focusing on consensus algorithms in the Ethereum ecosystem. So this was like, PBFT, IBFT 2.0, things like that when Ethereum was still POW and all these sort of Casper conversations. And that led me to, of course, Tendermint. That led me to focus on the Cosmos ecosystem, which is what I've been focusing for the last 3.5 years. Before starting Range, I was lead security auditor at Oak Security, doing mostly Cosmos SDK and Cosmos WASM audits. Also spent time doing like bug bounties and more than six figures in bug bounties. And I started Range about 2 years ago to solve what we think is the key bottleneck and one of the biggest problems in the industry, which is the security problem. And yeah, like a bit of about Range for the ones that don't know Range. So we are the blockchain security and intelligence platform with a lot of focus on sort of like post-deployment security. We can go a bit deeper on that, what is that later. And we focus a lot as well in cross-chain monitoring and of course like the Cosmos ecosystem, IBC, and now as well Solana and SVM.
Yeah, awesome. So you are basically to blame for the fact that Ethereum doesn't have single slot finality, and that we need to deal with that. You were there during the time when they discussed what to do.
I wish, but no. Back then, I was just an intern. In a way, still I am an intern. But yeah, like I think it was like a super interesting time because like like most of the discussions at that time like were like about like technical things, and I feel maybe it's just sort of like this good old days feeling, but like people were very passionate about like this sort of consensus algorithm discussions and yeah, like I am though not like the cause that we don't have like single slot finality in Ethereum, but I'm sure that you guys are gonna find ways to circumvent that constraint.
Yeah. So for people listening here, like the type of consensus that the chain uses is very close to Union's heart because that is actually what we write like a light client for, what we encompass in a contract and what we track. So in our case, we usually dive very deeply in the white papers and the node implementations for different chains to see how does the chain actually finalize. Finalization is the process by which basically all the validators agree to never revert a block again. So in the case for Cosmos chains, for example, that is always immediately. So when a block is produced, all of the validators have voted on it. In the case of Ethereum, that happens periodically. On the top of my head, every 64 blocks. Although it's a bit more complex with Ethereum and the exact guarantees you get for the different epochs. And this differs for like many different chains, what that kind of algorithm is for when it finalizes and when you can truly trust that the block will always be there. You see this probably when you use centralized exchanges, because it will show you like number of confirmations. And that's basically waiting for a block to be finalized. And so we do the same deep down in the protocol. And that's kind of the fundamental like security guarantee that Union has on if the funds will not go to another account, like if they really are in the Union vault or if they end up somewhere else. That's why we need to wait on it. So yeah, I think maybe good to start off with a kind of introduction of what Range exactly does and how we're collaborating on this. And then afterwards, we'll dive a bit deeper into the ceremony.
Yeah, of course. And I think, like as we started the conversation talking about Ethereum upgrades, I think like another upgrade that can be like quite interesting to discuss was like the, one of the precedent ceremonies that happened, in this industry, like the KCG. But before that, just, like to explain what sort of like Range is about. So as I said before, we are the blockchain security intelligence platform. And what does this really mean? So Range is actually a platform with different verticals. We focus a lot on real-time security and alerting. So if we think about the security lifecycle in crypto, we make a clear difference into pre-deployment security. And this is things like audits, formal verification, and things like that, and then post-deployment security. So when your protocol is live, what can we do to make the protocol more safe, or at least be able to respond to incidents, operational or security in a faster way? Range as well has like a bunch of tools targeting like sort of intelligence and investigation tools. So that's another part of the security lifecycle, which is when you want to really understand what's going on in the blockchain you use, or actually in the breaches you use. As we know now, the reality is that crypto is very multi-chain. Like cross-chain activity is ever increasing, and of course, with projects like Union, this trend is going to accelerate. So we actually make sense of flows of addresses and transactions that happen between multiple chains. We do this through, like some visualization tools like Range Trail that can enable teams, from, like builder teams, but also like auditors or investigators actually understand and track wallets. This is very relevant when something bad occurs, but also before, just trying to understand like, what's going on and what type of wallets are interacting with your programs. We have as well what we call an advanced cross-chain block explorer, and we are the team behind the IBC and USDC explorers. This is again tools that we built mostly for the community and for developers to actually help them monitor transactions across chains. And then we do as well things that go with the objective to actually prevent hacks. One of the major initiatives on that direction is our work with IBC rate limits, and that's projects that we've been doing in collaboration with teams like Osmosis or Neutron, and here the key is we build and help design on-chain safety programs and business logic that can, like cap the downside if something bad occurs. And as we can see, as we all know here, like this gets very relevant, like for breaches, which historically have been like the biggest exploits in crypto, and basically with this IBC rate limits, you kind of contain the blast radius, and it's in the same way as putting you like your seatbelt, right? So even if something bad happens, like let's say the injuries in the protocol, or like the amount that is at risk is greatly reduced. So in a nutshell, we do a lot of things in the sort of like security, risk mitigation, and intelligence realm, and with a lot of focus on the Cosmos ecosystem and as well on cross-chain and interoperability activity.
Yeah, awesome. And obviously, to shed some light for people listening in, Union is working with Range So we're basically leveraging them as well for a cross-chain explorer. Although we provide our own, I think it's good to have like multiple implementations. And I think unless the implementation you guys have is like the nicest power user implementation, right? With all the bells and whistles for researchers and such. With ours, it's more geared towards end users, as well as we provide the GraphQL API that developers can integrate in their own apps. So you don't need to rely on multiple indexing services. If you write a cross-chain app, you can just use Union's API, and you get kind of the full transfer and transaction traces of everything that is ongoing in the system.
Yeah, and we are super excited to be collaborating with you guys. As mentioned before, I think interoperability protocols and Union in particular can be like sort of like the nexus of many different blockchains and networks, and these make them sort of like systemic in a good way, because there is like a very strong network effects, but also they become very relevant for like the security, not just of the bridges themselves, but also the whole ecosystem, right? And I think it's just super exciting given the many routes that Union is going to be opening up between different ecosystems. Like just be able to work with you guys and go to the places that you're going to be sort of like opening the routes and just making sense of all these cross-chain volumes and trying to make all this sort of like cross-chain activity more safe and secure and also available for users and developers to actually understand it.
Yeah, at least the way I see it. We would see a lot of people talk about like application-specific sequencing at the moment, which, to be honest, is just another form of app chains or app-specific rollups. But the trend that we just see is way more applications are going to their own state machine, and the state machine really is just a blockchain. So that means that fundamentally, even though like don't worry, like we don't expect end users to like be bridging themselves all the time, but under the hood, a lot of applications will be bridging in between each other fully automatically. And so I kind of think the world we're heading into with the next bull markets, the next few cycles, is that crypto is going to resemble TradFi much more, with like massive amounts being cleared and settled in between banks every day, the same as what we're kind of seeing between blockchains. And right now, to be honest, the volumes, they've actually risen a lot. It's kind of unthinkable that nowadays we're bridging as much daily as like the market cap of many like top 10 coins about 8 years ago. But I think it's going to go up from like a couple of billion a month to trillions in total being cleared and settled all the time. So parties like Range are indispensable for keeping that secure and keeping track of these asset flows. And for me, at least, like I want Union just to play a role in making it super easy for anyone to tap into this.
Yeah, I mean, 100%. And I totally agree with sort of like this vision that you have. And I guess the sort of like ideal that many teams are working in the space and something that is being spoken about a lot, which is sort of like this chain abstraction idea, right? Or even like intents and things like that, which, I think the end goal is that hopefully the users are going to be forgetting slowly, like all these sort of cross-chain words and things like that. But the thing is that under the hood, this is ever increasing for the reason that you just said, right? If applications are going to their own state machines, even if projects are able to abstract this from the users, like there's still going to be a lot of cross-chain activity or like actions and intents between addresses and entities from different environments or state machines. So yeah, like the trend is, I think, accelerating, and yeah, like it's pretty clear that in the next couple of years this is only gonna be increasing.
Yeah, 100%. And that's kind of like one of the reasons that we originally founded Union was we were a group of developers ourselves thinking, what are we going to build next? And in the end, what you end up with is, if you want to build like a really good product, you're going to end up with an app chain yourself. The mode that like Hyperliquid or DYDX4 has over smart contracts is so big that if you want to build like a really good product that's really good, you actually kind of have to go in that direction. But at the moment, there's still like a lot of infra you need to build yourself. Like getting bridge support is like a 6-month journey. So with Union and kind of a cluster of companies around us, that's what we originally sought to solve, to make that not a 6-month journey, but just something that you kind of finish in the first day, that any builder has access to. I think that's the big unlock for smart contracts, to make the migration to app chains or app rollups, and then with chain abstraction and account abstraction, making this palatable for the user as well. So it kind of seems like we have just a big swarm of chains that communicate like one. Same experience as Solana, the monolithic chain, has between all of its apps.
Yeah, I mean, the thing, if you think about it, like, I think theoretically, like, yes, having your own sort of like app chain or app rollup has made a lot of sense for, already quite some time. But the reality is that developers until now had constraints. Like one of the key constraints is, of course, like the paying for security type of, like inflating rewards, paying for validators, which, like this is of course being solved by like all these sort of roll-up focused projects. And the other is liquidity, because like if you sort of like are kind of separated to the world, like you need to bootstrap all that. But that second piece, which is very important, is being solved by projects like you guys, like Union. So yeah, I think like if all these boxes get checked, like the arguments to not launch in your own sort of like state machine keep getting like smaller and smaller until it's going to be just a no-brainer for every team to just be their own, like chain, roll-up, whatever we call them.
Yeah, I think indeed, like 3 years ago, maybe as a builder, like the indeed most significant argument would be, like, does your app require like a distributed peer-to-peer network of 100 nodes plus RPC nodes to operate, right? And you saw a bunch of app chains in the Cosmos ecosystem where, even though the application is really good and they have a decent amount of users, it isn't big enough to warrant such an infrastructure investment. And then you just have to pay such massive emissions to your validators that the token is down only. But I think we've actually reached the era where we have solved this. I don't think we've solved it with like restaking and buying security from other parties. I actually think we've solved it with rollup technology, and especially being able to do ZK rollups. That to me is like the best solution, to not need to pay a part of your revenue to an exogenous security set, right? Like people want to have their rewards go to their own token holders, not to ETH holders, for example. While at the same time, like having the same security guarantee as a full chain has, and ideally, like not needing to manage that big peer-to-peer network, right? Like having just one big rollup node on a machine is much easier infra for startup to run, and then you can decentralize it down the line by having multiple, doing a decentralized sequencer or something for failover protection. But that works even if you only have like 4 to 6 sequencers, right? Then you are nicely distributed, but you're not paying for 100 validators.
Yeah, I mean, I think and I think it's been quite interesting to see sort of like in the last couple of years where it did seem that, like for rollups, like everyone thought that the crypto economic approaches were going to be faster to market and be sort of like a transition period until CK technology was ready for prime time and just be able to replace this as the sort of like end game solution. But it seems that the opposite has been true. I think surprisingly, or at least for many people in the industry like myself, how teams and CK technology has been able to advance that fast, and then on the other hand, like sort of like more crypto economic solutions and sort of like optimistical type of solutions like have seemed to be harder to get to production level with float proofs and everything. So yeah, like it's a quite interesting development, and it seems that also like that's the kind of a thought process and a design decision that you guys did while doing Union, which is kind of very in contrast to other of the interoperability solutions, which lean much more on the sort of crypto economic warranties against the ZK tech.
Yeah, because I think the crypto economic solution, so basically optimistic with fraud proofs and making that open, decentralized, like allow anyone to dispute and making those systems work. We've kind of seen them go to production and then being taken out of production again. Like I don't think we've ever seen them be successfully executed or like go through a full test run and show that they could actually work on mainnet, as well as them being live for a significant amount of time. And now you're seeing like ZK being fast enough to actually migrate these optimistic rollups to ZK. So that'd be my recommendation for any builders listening here in this chat. Like if you're thinking I'm going to do my own rollup, do I go for an optimistic stack? Optimistic seems to like be faster to get off the ground initially, but I don't actually think it's that much faster because you need to run like different watcher nodes that could dispute. You need to periodically basically fake a dispute on your testnet to make sure that that whole protocol still works, so that you could end-to-end kind of play the disputing game and resolve to the correct settlement. While with the ZK rollup, sure, you need to get like one server with a GPU to be able to produce proofs. Or nowadays, like you can just use proving services like Bonsai or Synctus running or Sindri to have it be performed for you. And you're off the rails. You finalize immediately. You always know that you're fully secure, and there's no need for all these watcher nodes, disputing nodes, stakes being put down, etc. So I much prefer that model overall, and it's easier for Union to work with too, because for optimistic rollups we actually see higher bridge latencies. Those of you who were on our testnet probably noticed that going into Arbitrum is fast, but out of Arbitrum takes a while. That's because we need to wait for Arbitrum's soft finality to occur. If Arbitrum was just a full ZK rollup, we would be basically able to bridge out of it much, much faster. So Scroll, for example, is a rollup we prefer working with at the moment from a tech perspective. Nothing on the team specifically here, because it's a ZK rollup. And at the moment, I think they settle on mainnet like every 2 minutes. They're looking to settle every 1 minute. And that really involves the UX on our side. It makes the whole protocol much easier to build, much easier to track. Kind of low-key, my dream is for all of the ZK rollups to just settle every ETH block or every other block. That's how we get like the ultra good UX, where we see like bridge transfers being completed within a single block time.
Yeah, I mean, I guess that I guess it's not a caveat, but the only thing that like these ZK tech systems like need to do, and that's I guess the protagonist of the week and the month, is sort of like the trusted ceremony itself, right? So yeah, I mean, I love to dig a bit deeper there, just because how timely, and also because what I've been seeing from like from your Twitter, maybe you can share more information there, is that like it might be like one of I'm not sure if the largest, but at least one of the largest, and like I'd love to know like studying like previous trusted ceremonies, like from the very OGs, like the ZK Cash and like sort of like the most recent ones, like the Dank sharding one from Ethereum. Like, how have you guys thought about this sort of like 0 to 1 critical step for Union and the whole like zero knowledge proving system?
Yeah, of course. So for people listening in that just want to know a bit more of the background, so the ceremony is basically needed to generate the verification keys, which are like sort of public keys that go in our smart contracts that can verify our ZKPs. And so we store these in the Solidity smart contract that we deploy on Ethereum and on Berachain, and in the Move contracts that we deploy on Movement, and the same on the Solana ones. What we did so far for testnet was we generated those ourselves with the Union Labs team. But this generation process has one critical step. While generating, you generate a few random numbers, and those random numbers need to be deleted, because if you don't delete them, you can later basically hack the smart contracts. You can create ZKPs which are not valid but will be accepted by the contract. So it's very important that these numbers are safely deleted. Now, obviously, like, we trust ourselves at Union Labs, we built the protocol, but the wider crypto community cannot technically trust us, right? We're humans after all. We could have been hacked. We might have had a North Korean developer. You don't know what can occur. So there's basically a solution to de-risk this, which is don't have one computer generate this number, but do it over many computers. Obviously, if you have all of the Union Labs team members participate, you've already de-risked it, because if one of them turns out to be like a North Korean hacker, then at least like you've spread it out over the team, and so it's no longer vulnerable. But even better is if you just open it up to the community, right? Instead of 10 people participate, have 1,000 people participate. And the way this setup works is, as long as one person in the whole chain of people participating truly like deletes the secret numbers that have been generated, then the full sequence is secure. Like, even if 99.9% of the participants were all North Korean hackers, as long as there's one honest contributor participating, then in the end, our circuits are fully secure and the system itself is secure. So the approach we've chosen ourselves is the Union Labs team participated first in the ceremony. We mainly did that to just test the UX. Now we're in the private phase. That's where we reward some early contributors, some partners that have been working with us so far, and ensure that they can participate. Where we actually handed out invitation keys at Token 2049 as well in Singapore. So we had a whole bunch of different founders there already join us in the ceremony. And the second phase, which is where we open this up to everyone. And that's where we expect the largest influx of participants to come from. Now, looking a little bit back historically, you mentioned Zcash. I think they went in a forest, right, together. They truly did the ceremony, as in, like, leave your mobile phones behind. We're all going into a forest with a laptop, and we each put in our numbers. How did they do this again?
Yeah, I think like it's so it feels like from another age, because I think the trusted ceremony was just sort of like 6 different parties, or 4 even. I don't recall exactly the number, and I think each of them went very deep into finding different sort of like random number generators in weird ways, and then sort of like destroy their, the systems that they created the keys with. So I guess it's sort of like at the other end of the spectrum. Like when you have like 4 people, like the risk much less, so you're kind of relying more on the trust in some community members. When you go from sort of like massive amount of community participation, then you are the risk in the sort of like this trusted ceremony in a totally different way. And yeah, I mean, I think it's just kind of also looking to it from with my security hat on. I think like the property of just having one honest participant is very strong. I think like you guys have done an excellent job just making all the components open source and making it easy for third parties to verify as well that some of the components in actually executing the ceremony, like the MPC system itself, like can be audited by the community and it's open source. So I think that's something quite powerful. And actually, I was trying to time my ceremony participation exactly as we are doing this space, but I guess that you guys have done a good job, like just distributing this to the community, because like I've been in the queue for about 1 hour. So right now in the queue for the ceremony, like this is about 50%. Maybe I'm gonna be actually participating in the trusted ceremony towards the end of the space, which sort of, I guess this gets recorded for posterity. And I guess that's in terms of numbers. Do you guys have sort of any expectation of the numbers of participants that you expect to have?
Yeah, so the number of participants kind of depends on the hardware of the participants themselves. So for the people that have participated already, you might see in the UI that you get a slot, and the slot is a 30-minute window in which your computer can generate those random numbers and participate. What we've noticed is that the quality of the hardware that people use for the participation differs a lot. So for some, they're kind of done contributing in about 6 to 7 minutes. Others, they barely make their slots. They're like done in 29 minutes or something like that. So if on average it's 30 minutes per participant, then really you can only at most have 48 participants per day. Then the next thing is, how long do we want to let the ceremony run for? That depends a bit. Most likely the public portion will run for approximately a month. So people can do the math on how many participants we'll have at the least and at the most with the numbers we have so far. According to our calculations, like the wait list already exceeds how many will be able to participate. And that's just kind of a fundamental limitation of, I'm afraid, the potatoes that people use to calculate on. For those that might miss this, there will probably be multiple ceremonies for a union, because every time when we have a significant performance upgrade for our circuits, we might need to do another ceremony. So there's types of performance upgrades where we just make the prover faster, the off-chain infra, where we get that server to be more optimized and generate proofs faster. There's also an optimization where basically how our circuit is compiled becomes better. And in that case, the verification key changes and we need to do another ceremony. So I kind of expect that probably once every 6 months to 1 year, Union will do a potential ceremony to upgrade certain contracts. We'll just have to depend on what the performance gain will be. So if we can get a 50% faster proving time, that's very significant for the UX. And so then it's worth it for us to run a ceremony again with rewards for the community that participates. So for this one, we basically have the patron NFT to show that you really helped us create the union, as well as for early supporters on our testnet. And then for the second one, we need to figure out how we reward you.
Yeah, and I guess just from my sort of like side as a community member, yeah, I would just encourage everyone to participate, because I think it's fun. You know, like it's one of these things where technology is, I mean, I wouldn't say it's like magic, but it's just very cool to participate in a multi-party computation protocol like a CK trusted ceremony. So it's nice that you get an NFT, but I would just say like just do it because it's pretty cool to be coordinating in this way with like random folks all over the internet just making a protocol sound.
Yeah, I particularly like this because you're truly helping us make Union a lot more secure, right? This isn't just some, I don't know, publicity stunt that we're doing. This isn't referral codes to get additional points. This is actually a critical step to make this system secure. So I think everyone that manages to participate should actually feel really proud of doing so. You've helped make something great and basically facilitate crypto becoming, once again, a little bit more decentralized and a little bit more secure. I think that's always something to strive for at the end of the day.
Yeah, 100%. You know, like I'm not sure exactly like how long we have the space schedule, but there is something that you know, we have time. Like, we'd love to dig a bit deeper with you. And that's something that, like we've chat about, and I've seen you like also tweeting, which is and something that I think a lot about, which is sort of like the difference between theoretical security and actual security for breaches. And what I'm getting to is that, as we know, like there is like a lot of these breach hacks in the past have been actually not like design flaws, but actually configuration or implementation flaws. And you see like in many breaches, in the ecosystem or many interoperability protocols that talk a lot about their sort of security properties and their designs and how secure they can be. But actually, when you look at the different configurations, they ended up being sort of like in the minimal, secure, and decentralized way that you can actually configure these systems, right? Namely, like 1 out of 1 or 1 out of 2, like, or 2 out of 2 multi-sigs. So I'd love to get your thoughts on that, and like how, and also how Union compares to those systems in the sense of what's like the minimal security configuration for Union, and the default one, which is actually not just the theoretical, but actually the implementation of Union itself, right?
Yeah, exactly. So just for people wondering what we actually mean by like what's the theoretical security and then a configuration mistake. So a lot of the times what a project will describe in their white paper with like fancy algorithms, formulas, etc., that portion is actually secure. But when they then write smart contracts, put in the numbers, configure these contracts and deploy them, they make a mistake and they don't actually implement what's in the white paper. And usually this occurs not when they first deploy it, but might occur actually like a year down the line when they've performed a few upgrades, because they might have been like secure originally, and then like there were new devs coming in, they added some new features, and while adding a new feature, they reverted the security measure. I think Li-Fi is a good example of this, right? Where they is it twice or 3 times they've been hacked because of they kind of add extensions and new features to the protocol instead of the original code base. With bridges, there definitely have been a few cases where like the fundamental protocol is just insecure.
Well, yeah, like
example, right? Which is
Ron is an example.
Yeah.
Like, all the multi-sig, exploit, like Axie breach, like that. That's definitely like a design exploit.
Yeah.
You can configure it. Like you can configure one of these more like message swapping protocols as well to rely on a multi-sig. So if you are able to get hands to the multi-sig, like you are actually exploiting the design as well, right?
Yeah, exactly. So anything that's like multi-sig, I would say like if the multi-sig participants get hacked themselves, that's a design flaw. Like that, the system was fundamentally vulnerable to this. That's not an implementation detail that you missed. Like that's just because you chose a bad design for the bridge. Then you had Nomad, and Nomad just made a mistake in their smart contract code. Like I don't think they were audited at the time too, so that was a bit on the company itself. But I think their protocol was fundamentally quite sound. Still a bit risky with like always need to have a disputer live for their Oracle updates, but fundamentally sound, and they got hacked because they just had errors in the way they coded their smart contracts. Now, how I see it right now in the bridging space is we kind of have like 3 categories. We have intent-based bridges, which use an Oracle to repay market makers / solvers. They are vulnerable to have their Oracle hacked, and the funds that are like at the moment locked to go back to repaying solvers, those could be stolen. We haven't really seen that occur, and that's usually because these oracles have like high latency to them. Like they're very slow to create a proof or a update on chain, and there's loads of layers to stop this proof from arriving. Which isn't great for solver UX, which takes a while for solvers to get their money, but keeps it quite secure. Then we have what you see layer 0 v2 do in XOR now as well, where there's like all of these different configurable security levels different like verification contracts that have a certain stake associated with them, and loads of configuration parameters and high customizability, which Hyperlane has as well. And then you have protocols like Union, where there's basically one big like security level, and everything that goes through Union is at that security level. There's one ZKP to verify, and there's not that much configuration for individual chain, at least it's as little as possible. I like our approach more because, like you said, a lot of bridge hacks are actually due to configuration error. So I don't really like the model where you have to think as a developer, like which DVN do I pick? How much security do I decide? I put it at like 40% this, or this is a subset of operators I trust, because that just gives you so many things that you need to get correct while configuring your bridge service, that there's a lot of room for errors for this to go wrong. Well, basically the philosophy of just put HTTPS everywhere, right? Put everything at the highest security level you can. Don't make builders that use the service think about security. I think that's better to reason about overall. And that's better for protocols building on top to reason about, right? Because you don't want to think, oh yeah, I'm a cross-chain protocol communicating with another cross-chain protocol. They're using DVN3, which is backed by a dual stake of Chihuahua coin and 3 operators, where like all 3 are anon. Like, can I actually trust the bridge messages coming from that? Probably not. And that's, I think, how we see like a lot of like avenues for attack. And the other thing is, the more you can configure, like the more middleware you can add yourself, the more you have to implement as a developer, the more technical debt we create. I think Hyperlane is a nice example of where basically it's just an open source set of libraries that you can use, and you can even like implement it yourself and deploy it. But that means that there's no wider network effect. There's no like wider maintenance ship. So there could be routes that have been created like a year ago that are still kind of operating, that are vulnerable because the people who originally deployed them like never updated them. So limiting how much technical debt is out there and kind of like centralizing that under one umbrella, I think it's much better for security overall.
Yeah, I mean, I think that this sort of corresponds to like a fundamental truth, but not about sort of like cryptography or distributed systems, but sort of like human psychology, which is like I think like we tend to be lazy, we kind of default to the least resistant path, and like if you inspect a bit like the of these sort of like modular configuration systems, like if you look a bit under the hood, like the huge majority of the value secure is actually like on the simplest configurations, which makes them kind of like very, very simple, like multi-sigs or even EOAs. So like one address actually being the central trusted, weakest link of the protocol. So I think like just making it sort of like mandatory, as I think like the HTTPS everywhere, like it's a great analogy. I haven't thought about it. I think it's a great way to put it. So yeah, like I think that this approach is quite smart, and just make it like a bit more of a standard. Hey, this is how you make interoperability better. And in terms of then in Union, like if you make these default secure enough, and you sort of like limit the design space for upgrades or developers to actually mess up on the like bridge integration and configuration, like what's in your mind? How do you think about like the rest of like how you think about the security union of Union itself, right? Like once the trusted ceremony is done and the CK prover is up and running and everything is going fine, like how do you think about the threat model? Like as I understand it, like as a user, you need to, of course, trust like the Union validator set, which is sort of like going to be like a normal Cosmos POS system. But how do you reason about like the making like a union even more secure and also at the implementation level?
Yeah. So, like we'll be actually from all three guys like publishing our long-term roadmap soon as well with all of the big ticket items. The thing I'm looking forward most is kind of total proof aggregation / proof singularity. So we're working on the first few POCs of this right now. That basically means that there's no assumption at all on union whatsoever for providing any security. Like it's always 100%, and there's no assumption on the validators at all. There is, well, that is a security assumption. It depends on how you classify it. The validators could potentially censor a chain in that system. So it kind of has the same guarantees as a decentralized sequencer network then. Where as long as like one of the validator is honest, like there will be no censorship. If all of the validators are dishonest, all funds are always secure, but there could be potential censorship. That I think is probably the best you can ever do with the ZK bridge actually, as a system where you do proof aggregation. Something else we've been working on, you can find that in our research, is state lenses. What's kind of cool with state lenses is it removes PFM completely. So actually in production, Union will not be running packet forward middleware, but instead kind of creates these virtual channels between chains. What's cool with that is you then actually have access to the state root of the two chains communicating over Union with each other. And that means that you can, for example, leverage naysayer proofs. So before we actually go into this proof aggregation world, you could configure your client contract to accept a disputer address. And that disputer address could be a multisig, or could be Range's address, or could be a contract that verifies EKPs. That's all fully flexible. And that is what a chain can use to basically shut down the bridge or pause it for a certain amount of time in case something goes wrong here. So that ties a bit into like IBC rate limits and having like some sensible ways to pause the bridge in case a hack is ongoing. Because there's of course like many cases why you might want to do this, right? It could be that Union itself is still fully secure, but the chains that were connecting with each other, one of the two chains itself has been hacked. In that case, you still probably want to actually pause the bridge for that duration to make sure that no funds get sent to different chains, and now there's unbacked tokens out there. So
yes, sir. One question there. Like, is that like, can you like pause like a specific routes, or like would be sort of like a more of a system pause during the specific time?
It's you can pause specific routes, or you can pause on like the destination side all routes as well. In this case. So basically what you can do is you can create a proof saying Union has incorrect state data for bearer chain, right? And deliver that proof on movement. And depending on that case, you could then choose, all right, like if Union has incorrect state data for a single chain, we're just going to pause everything, because that means something has gone horribly wrong, right? Like could be Union that's been hacked, or could be that specific chain. For now, we don't care. Just pause everything while the devs figure out what's going on, which I think is a really sensible default to have.
That's very cool. That's very cool. And that, if I understand it correctly, like that would potentially be even complementary to like IBC rate limits in the future. Like if I'm understanding the mechanism correctly, like in this case, you would be sort of like a post function for the system, and rate limits could be just potential caps down the line on sort of like the value at risk that you want to put like for a given route.
Yeah, exactly. So basically, like depending on the different chain ideas, you could set different contract addresses on how you want to dispute them. So if you want to generate a CKP with risk 0, for example, for the block header, in that case, like if you generate a different CKP with risk 0 that leads to a different header than you do with than Union provides, then you know something is going wrong. There could be that the origin chain is undergoing a 51% attack, for example, right? And having massive reorgs, and that's why you're shutting it down. And the other level is indeed the IBC rate limits, which I would say is more application level security, right? More about like, has a DEX been hacked, and do you want to pause that?
Yeah, no, 100%. It's sort of like application level also at the the level that it operates mostly at the token swap sort of ICS 20 level. So yeah, probably like it's at a different layer of the stack and could be very complementary. But yeah, it's very cool that you guys are thinking on default fallbacks that especially at the beginning of protocols. Like I think historically interoperability protocols haven't thought too much about it, and in the case of like events of Nomad, for example, that we saw it being exploited like in real life for a long time, like could have saved the project pretty much. And as you said before, like was like a sound design, but there was this sort of implementation issue, and just having these systems in place as you guys are doing, like can sort of separate a bad day for the devs to actually just sunsetting the project. So yeah, I'm very glad to see that you guys are thinking thoroughly on that as well.
Yeah, and for people listening in, like these security measures are not backdoors. But we, for example, could configure the system to allow range security to pause a specific route, but that wouldn't mean that they could take tokens out of the route. They would just pause the transfers ongoing, and we can even configure it in such a way that they can pause it for 6 hours, and then it will automatically resume, or like a larger multi-sig needs to continue the pause. And that will prevent, for example, the Nomad hack, because the Nomad hack occurred, I think, while the whole team was partying. So people were emptying the bridge protocol and no one could actually contact them at the time because they were all at a conference. So in this case, what you want is for a security company to just temporarily pause the bridge, wake up the devs. The devs can have a look at what's going on, and then you can use a multi-sig with much more participants, let's say 40 different participants across the sector, to prolong the pause. And even nicer, of course, is if it's not a multi-sig, but governance for a specific chain, right? So you could say that this 40-person multi-sig can only pass for 2 days, and then the system goes live again, unless governance of the specific chain decides to prolong it even more. And then you have a really nice mixture of very high security, but also decentralization in the end, where if the US government orders the security councils to pause, they couldn't pause forever. And that's kind of my favorite combination.
Yeah, no, I agree. And yeah, I didn't know the whole backstory about Nomad, but yeah, I think that especially like given that like these temporary freezes, especially for systems and bridges that are not sort of like very Oracle related, like they don't really change the trust assumptions, as you said, of a system, and especially like if you make this specifically temporary, right? So even the DOS or like denial of service of like just like someone with the POS ability going rogue and trying to pause the system for to just make it unavailable when sort of like these freeze functions default into a like maybe governance that can actually impose it and things like that after like some previous time. Like I think it's very smart, and I think that some of the largest projects like that have like Wormhole, for example, that in the past like had like this, of course, like this massive exploit. Like they've implemented things like that, like with the Wormhole governor. So I think just starting from the get-go with these sort of systems, as you guys are doing, like it's just a massive advantage, I think, because like you can sort of learn where other protocols or systems have been burned in the past, and just sort of like start with a blank slate with all those checks in place.
Yeah, exactly. All right, I think we're kind of arriving at the end of the time we have for this space. Is there anything like alpha you want to give us for what you guys are doing at Range? Because I saw some new features announced recently that I've been keen to test out overall with regards to the Explorer and such.
Yeah, so basically we pretty much relaunched the whole Range platform last week, and I think we've had like a bunch of new features, but I think the most important one is that we are pretty much opening it up for everyone to use. So like we have like sort of two different platforms, like the Range community platform and then the the sort of like more enterprise ready that we work with teams for like real-time security investigations and things like that. But the community platform right now, it's open to everyone, and includes as well like an advanced block explorer. So you can actually visit that at app.range.org. You don't even need like a sign up. So it's sort of like you can think of it as just a battery included, cross-chain explorer, and you can start doing like a lot of things, just investigating even your own wallets, or just using it as a normal explorer, and even tracking in real time like all IBC transactions. So I would just like we made like this very important decision that a lot of the infra and products that we were building were actually not just helpful to for like the developer teams that we work very closely with, but like they could be very useful for the community at large, and also like developers that we might not know personally. So yeah, like if you check out like our page at range.org, or even just the platform directly, you can start using Range by the get-go. You don't need to jump into a call with us, or get a demo or anything, which is kind of like what a lot of the security and intelligence like platforms default to, and we are making this sort of like open for everyone. And yeah, we announced as well full Solana support. So basically like we are supporting a lot of your favorite Cosmos chains, like of course like Osmosis, Neutron, Cosmos Hub, DYDX, Celestia, Dimension, many others, and now as well like full support with Solana. And I guess one of our goals for the next couple of months is also to cover majority of the cross-chain volumes of the space, and we are going to be incorporating this into the Range platform as well. And yeah, like a lot of these volumes are going to be coming from Union, of course. So yeah, like very excited for this collaboration as well.
Yeah, exactly. I see already a couple of teams that we are working with to build products on top of Union here in this spaces. So I'll make sure to create some Telegram channels and connect you with them, because we definitely want to monitor some of the order flow they're going to be sending around. And then for everyone listening, if you're more interested in the ceremony, like keep following our Twitter, and make sure to sign up for the waitlist if you haven't received the key yet, to get an early heads up for the public portion. Public portion, as a heads up, most likely the queue will fill up within the first 10 minutes. So getting that early heads up and being behind your computer and like ready to join the queue ASAP, that'll like be the best chance for you to get a spot. Because right now we have I think almost 15K real accounts waitlisted with the software installed and ready to go. And probably out of those, about 2 to 3K will be able to participate. So you really need to be ready to run if you want to have a decent chance. All right, Andres. Thank you so much for coming on. And thanks everyone for listening.
Yeah, thanks so much for having me here, and also thanks everyone for listening. Bye.
All right, ZKGM everyone, and see you all around.
ZKGM. Take care, everybody. Bye bye.